Namaskar मित्रांनो. Till now we have seen single phase circuits. Now we are moving towards three phase circuit. But why to go for three phase circuit? The single phase system or single phase circuits, whenever we are using, we can use it for small scales like our residential purpose. But three phase system is required for commercial system, industrial system, because single phase system has low capacity of carrying power, but three phase system has more capacity of carrying power, as it has three different phases. In single phase only one phase and one return path is there, but in three phase we are having three different phases, so simultaneously they can carry the more power from generating station to the distribution section or where we want to use the electricity. Okay, सिंगल फेज वापरून आपल्याला एकदाच बल्क पॉवर ट्रान्सफर करता येत नाही किंवा जनरेट सुद्धा करता येणार नाही. बट थ्री फेज जेव्हा आपण वापरतो, अल्टरनेटर म्हणतात, हायड्रो पॉवर प्लांट, स्टीम पॉवर प्लांट आणि वेगवेगळ्या पॉवर प्लांटमध्ये यूज होतो. अँड वी आर जनरेटिंग द पॉवर इन अ थ्री फेज सिस्टम. ओके, अँड इट कॅन बी कॅरीड फ्रॉम द जनरेटिंग स्टेशन to the distribution part where the locality is there or industrial zone is there, and this distance is very large, more than 1000 kilometer, 2000 kilometer. Okay, so at that time if we use single system, it is not so easy to transfer the bulk power. That's why three phase system is required. Also the power factor of single phase system is less than your three phase system. The water instruments we are using in a three phase, suppose single phase motors and three phase motors, the single phase motor have less efficiency than three phase motors. Okay, so one more thing, the if you see single waveform is there in single phase system, so power get fluctuations continuously, it will get fluctuating, but in three phase system the overall power remains constant. Okay, so three phase system can be used for high voltage levels. A single phase system we cannot use for high voltage levels. Okay, so these are the advantages of three phase system over single phase system. Now the generation of three phase system is similar to single phase system. There is a magnetic field and in that we are rotating the coils. So instead of one coil we are having three different coils which are rotating by keeping their distance, that is angular distance, as 120 degree. Okay, so one phase, one coil is of red. See here, R, Y, B are three colors used, color codes used in a three phase system just to indicate the phases. Actual conductor जो असतो त्याच्यात काही लाल कलर फ्लो होतो किंवा हिरवा कलर किंवा कुठला रंगाचा कलर फ्लो होत नाही. So it is a insulation which is we are providing for each phase that indicates the red, blue, yellow and blue color. So RYB is called as a phase sequence. Means what? R is a reference phasor which is starting from 0. Yellow phase is lagging by 120 degree with respect to red phase, and blue phase is lagging by 240 degree with respect to red phase. इथे आपल्याला रेड फेज आहे, त्याच्यानंतर 120 डिग्री लॅगिंग इथे येल्लोच्या जागी आय एम युजिंग ग्रीन पेन. ओके, ग्रीन इंक. ओके, सो green is lagging by 120 degree, means if it is anti-clockwise direction, red will be always ahead, after that yellow will come and after that blue will come. Okay, so we are having the voltage equation as usual. VR or VR is equal to Vm sin omega t. Yellow phase Vy is lagging by 120 degree, so Vm sin omega t minus 120 degree, and VB Vm sin omega t minus 240. You can replace this minus 240 by plus 120 also, because omega t minus 240 is nothing but omega t plus 120. Okay, if I draw the waveforms for each, red phase is starting from 0, yellow phase is starting after 120 degree, and after 240 degree the blue phase is starting. The Vm is maximum voltage attained by all the phases and it is constant, and if you see at any instant of time, if you find the voltage, it will give me 0, average value as a 0. So V is equal to VR plus Vy plus Vb. If I prove this, V is equal to Vr plus Vy plus Vb. I put the values here or waveforms, that equations over here. We are knowing the formula for sin C plus sin D in trigonometric relation. That formula, if I use for this, at the end I will get total voltage of three-phase system becomes 0. Okay. So voltage at any instant of time, if you find it, it will give me 0 value. Now we will see the types of connection of three-phase system. There are two types of connection we will get. One is star or Y, and another one is a delta connection. Okay, in star connection, again we will be having three-phase 4-wire system, and this is three-phase 3-wire system. In delta we are having only 3-wire system. Okay, star connection means what? The load which is connected in star is star. So एक red phase आहे, white phase आहे आणि blue phase आहे. So star connection is there. If you are, it is a balance system. Balance means म्हणजे काय? तिन्ही फेज मध्ये इक्वल करंट फ्लो होतोय, म्हणजेच इक्वल लोड आहे, इक्वल करंट फ्लो होतोय. अशा वेळेस त्या सिस्टीमला बॅलन्स सिस्टीम बोलतात. ओके, तर सिस्टीम कॅरिंग इक्वल करंट इन ऑल द फेजेस इज कॉल्ड द बॅलन्स सिस्टीम, अँड दॅट्स वाय टोटल करंट अवेलेबल ॲट दिस कॉमन पॉइंट विल बी 0. So this is your neutral point, and this, in a balance system, this neutral connection is not required. Okay, if the system is unbalanced, अनबॅलन्स म्हणजे काय? एका रेड फेज मध्ये काहीतरी वेगळा लोड आहे, वाय फेज मध्ये वेगळा लोड आहे, तिघांचं वेगवेगळं आहे. त्याच्यामुळे काय होतं? तिघांमध्ये फ्लो होणारा करंट सुद्धा वेगवेगळा होतो, आणि तो करंटचा डिफरन्स जो येतो तो न्यूट्रल पॉइंटच्या इथे येतो. आणि जर ह्या डिफरन्स जो आलाय करंटचा, सो दिस न्यूट्रल, म्हणजे आता काय बोलू मी ते? ओके, तर बॅलन्स सिस्टीम मध्ये काय होतं? दिस इज बॅलन्स सिस्टीम, आणि हे अनबॅलन्स सिस्टीम मध्ये वापरतो आपण. सो बॅलन्स सिस्टीम मध्ये जो न्यूट्रल करंट असतो हा 0 असतो, तर ह्याच्यामध्ये हा 0 नाही राहत, कारण तिघांमध्ये डिफरन्स येतो. अशा वेळेस ॲट दॅट टाइम वी हॅव टू कनेक्ट द न्यूट्रल विच इज गोइंग टुवर्ड्स सप्लाय. Okay, that's why the difference in the current will come in this neutral and it will flow towards the supply without disturbing the system. जर न्यूट्रल नाही लावला तर हा करंट जो आहे अनबॅलन्स तो सगळीकडे स्प्रेड होईल आणि सिस्टम विल गेट disturbed. That is, power system will get disturbed. We will get the fluctuations or vibrations in, if motor is there, it will start vibrating, or fluctuation will be there in the system. Okay, so that is your unbalanced system. In delta only we are having connection in a delta form, and it is totally, there is no common point between three phases. इथे काय झाले? सपोज हा रेड फेज आहे, तर ह्याचा हा पॉइंट R2 आहे, Y1 आहे, Y2, ब्ल्यू 1 आणि ब्ल्यू 2. सो तिघांचा एक एक पॉइंट जो आहे सेकंड टर्मिनल तो कॉमन झाला. पण डेल्टा मध्ये तसं नाही. R1 R2 हा Y1 ला कनेक्ट आहे, देन Y2, आणि B1 इज कनेक्टेड टू Y2 अँड B2. सो R1 अँड B2. सो एका फेजचा दुसरा पॉइंट दुसऱ्या फेजच्या पहिल्या पॉइंटला कनेक्ट आहे. कॉमन पॉइंट नसल्यामुळे न्यूट्रल नाहीच आहे. न्यूट्रल इज absent in delta. In star it is present. So this is basics of three-phase system. Let us see star connection first. I have shown three similar impedances connected in star at point A. So this is my red phase, 120 degree नंतर the Y phase and blue phase. It is connected to RYB of supply. Okay. Now what are the nomenclature we will see here? The current which is coming from supply towards the phase is called the line current IL. The current which is flowing inside the phase is called as a phase current IPH. Now for star connection, if you observe, this IL will come and enter in IPH without any bifurcation, and that means your line current and phase current are equal in case of star connection. Okay, see, IL is entering directly in a phase, so IL is nothing but IPH. Similar for other phases. The voltage which is measured across the phase is called as a VPH or phase voltage, and the voltage measured between two lines is called as a line voltage or VL. So RY, YB or BR, whatever we are measuring, that is nothing but the line voltage. And red, Y and B च्या across जे voltage measure करतो, that is called as a phase voltage. I have written this here. VRN is equal to VYN is equal to VBN, that is VPH phase voltage, VRY, VYB, VBR, VL is equal to line voltage. IRN, IYN, IBN is equal to IPH is equal to line current. So phase current and line currents are equal. But now if you observe, VL is greater than VPH. But what is the relation between VL and VPH? This is not exactly twice. Okay, that relation we have to prove की कितीनी VL VPH पेक्षा मोठा आहे आणि त्यासाठी गरज लागते ती फेजर डायग्रामची. So we will draw the phasor diagram over here. The first phasor I have shown here VRN phase voltage, second phasor VYN which is lagging by 120 degree. Again after 120 degree I have drawn VBN. So my three phase voltages I have shown. I want to find line voltage VRY. So VRY is nothing but VRN plus VNY. See, VRN plus VNY. We don't have any VNY here. We are having VYN. If I reverse this VYN, I will get VNY. So that's why exact reversal I have take VNY. And this exact reversal will do what it will do. This 120 degree will get divided into 60 degree, 60 degree. So VRN आणि VNY मधला जो डिफरन्स आहे तो येतो 60 डिग्री. ओके, इथे फेज करंट दाखवलेत मी, त्यांचं या डेरिव्हेशनशी काही रिलेशन नाही एवढा, फक्त एवढंच दाखवण्यापुरतं आहे की फेज व्होल्टेज आणि फेज करंट मध्ये 5 डिग्रीचा अँगल आहे. देन इफ आय कंप्लीट द पॅरलोग्राम VRN पासून इकडे आणि VNY पासून इथे, द इंटरकनेक्शन पॉइंट विल गिव्ह मी VRY. दॅट पहिला VRN काढला, VYN घेतला, VYN चा रिव्हर्स घेतला आणि दोघांचा पॅरलल ड्रॉ कंप्लीट करून आय गॉट VRY ॲज द लाईन व्होल्टेज. ओके, दिस VRY इज अ लाईन व्होल्टेज. सो हे रिलेशन मला युझिंग पॅरलोग्राम मी प्रूव्ह करता येईल. सो व्हॉट इज पॅरलोग्राम लॉ सेज VRY स्क्वेअर इज इक्वल टू VRN स्क्वेअर प्लस VNY स्क्वेअर प्लस 2 into VRN into VNY and cos of the angle between these two phases. So cos of 60. Okay, VRN square plus VNY square plus 2 VRN VNY cos of 60. पण आपल्याला माहिती आहे VRY is corresponding to line voltage. So VL square. This is VPH, 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 VPH will give me 2 times VPH square and cos 16 will be half. So these two will get cancelled. So finally I will get VL square is equal to 3 times VPH square, and that gives me the relation VL is equal to root 3 times greater than VPH. So VL is equal to root 3 VPH or VPH is equal to VL by root 3. So for star connection the relation between voltage is what? VL is equal to root 3 times VPH or VPH is equal to VL by root 3 आणि करंट साठी IL is equal to IPH for star. Okay, जर मला पॉवर काढायची असेल तर इट इज व्हेरी सिम्पल टू कॅल्क्युलेट. वी हॅव इन न्यूमरिकल वी हॅव टू कॅल्क्युलेट द फेज पॉवर. एक कुठला तरी फेज घेऊन त्याचं कॅल्क्युलेशन आपण करणार आणि त्या फेजच्या पॉवरला 3 ने मल्टिप्लाय केलं तर आपल्याला टोटल पॉवर मिळते. म्हणून P इज इक्वल टू 3 टाइम्स VPH IPH cos 5. बट समजा मला लाईनच्या टर्म्स मध्ये लिहायचं आहे. सो VPH आय विल रिप्लेस विथ VL by root 3. IPH is nothing but IL. So I will get this 3, I will split into root 3 will get cancelled. So final will be root 3 VL IL cos 5. So in terms of voltages of phase and current of phase, I will get 3 times VPH IPH cos 5. And if I consider line terms, it will be P equal to root 3 VL IL cos 5. Similarly, I can write reactive power and apparent power, that is Q and S. Okay. So this is for star connection. Similar type of relation we will derive for delta connection, but not for voltage, it is for current. Okay, so this is my delta connection with 3 balanced loads. Okay, if you observe here, whatever phase voltage we are measuring is same as your line voltage. So here we will get the first relation between voltage is that phase voltage is equal to line voltage. But the current is not same as a phase current, because here you can see IR is coming, it is getting splitted, or some other current is coming and getting added over here. So we have to prove this relation. What is the relation between phase current and line current? See here I have drawn IRY, IYB and IBR with a displacement of 120 degree. As per the KCL at point R, what is incoming current? IR is incoming, IBR is incoming, and it is giving me IRY, and therefore my IR is equal to IRY minus IBR. Okay, so this KCL I have applied to this red point. Okay, so now since IRY is there, IBR is there, I want negative IBR, so I will reverse this phasor of IBR. That will give me minus IBR, so required term. And that's why if I complete this parallelogram and draw the resultant, I will get the line current IR. Okay, the angle between phase current and the angle between these two phase current will be 60, and the angle between phase current and line current is 30 degrees. So using parallelogram, I can prove that IL is equal to root 3 times IPH, or IPH is equal to IL by root 3, similar to star. Okay, so P is equal to 3 VPH IPH cos phi. Instead of VPH I am putting VL, IPH as IL by root 3. Again I will get same power relation. So for both power formulas will be same, 3 VPH IPH cos phi and root 3 VL IL cos phi. So now what is difference between star and delta? First point is connection. Star is connected with one point of each phase is common. In delta no point of phase is common. Okay, एका फेजचा दुसरा पॉइंट दुसऱ्या फेजच्या पहिल्या पॉइंटला कनेक्टेड आहे. न्यूट्रल स्टार मध्ये प्रेझेंट आहे, डेल्टा मध्ये प्रेझेंट नाहीये. त्याच्यानंतर स्टार सिस्टीम कॅन बी 3 वायर और 4 वायर. डेल्टा इज ओनली 3 वायर सिस्टीम. करंट रिलेशन स्टार मध्ये IL is equal to IPH, in delta IL is equal to root 3 times IPH. व्होल्टेज रिलेशन स्टार मध्ये VL is equal to root 3 times VPH, डेल्टा मध्ये VL is equal to VPH. आणि power carrying capacity of delta is more than star. It is 3 times greater than star connection. स्टार कनेक्शन मध्ये समजा पॉवर 100 असेल तर डेल्टा मध्ये 300 असणार. सो 3 टाइम्स पॉवर कॅरिंग कॅपॅसिटी मोर असते डेल्टाची. अजून एक डिफरन्स आहे. आधीच्या फेजर मध्ये बघितलं आपण की VL जो आहे तो वर जात होता, म्हणजे 30 डिग्री लीड होत होता, आणि ह्याच्यामध्ये IL जो आहे तो 30 डिग्री मागे फेजच्या, सो 30 डिग्री लॅगिंग. म्हणजे स्टार मध्ये जो लाइन voltage is leading by 30 degree with respect to phase voltage. In delta, line current is lagging by 30 degree with respect to phase voltage. So this is the difference between star and delta. We will stop here. Thank you.